Welcome back. In this video, we're going to continue with section 1.1 by taking a look at some divisibility tests. What divisibility tests are ways of telling if you have a certain number, is it divisible by some other number or not? Where they're useful is especially when you're simplifying fractions. So to start, we'll take a look at the divisibility test for 2, which is probably going to be the simplest, and you probably already know it. If a number is divisible by 2, it's an even number, and its last digit is either 0, 2, 4, 6, or 8. So, for example, the numbers 24 and 518 are both divisible by 2. They're both even. The last digit of 24 is a 4. The last digit of 518 is an 8. And so that makes them divisible by 2. If the last digit is anything else, then it is not divisible by 2. So 63, not divisible by 2. 805, not divisible by 2. Okay, so basically even versus odd is if it's even, it's divisible by 2. It ends in either 0, 2, 4, 6, or 8. And if it's not, it doesn't. Okay, test for 3 is kind of interesting. This one involves the sum of the digits. So you add up the digits and decide, is the sum, that is the answer, is it divisible by 3 or not? For example, 27 we know is 9 times 3, so is divisible by 3. What's 2 plus 7? 2 plus 7 is 9, and 9 is divisible by 3. So that means that the original number, 27, is divisible by 3. Try that again. 5,181, a little bit harder to see if it's divisible by 3. However, 5 plus 1 plus 8 plus 1, that's 6, and 8's 14. One more is 15. Is 15 divisible by 3? Yes. Since 15 is divisible by 3, 5,181 will be divisible by 3. If the sum of the digits doesn't give you a number divisible by 3, then your original number is also not divisible by 3. 2,131, 2 plus 1 plus 3 plus 1 is going to be 7, not divisible by 3. So 2,131 will not be divisible by 3. 169, I'll leave it to you to check that one is also not divisible by 3. 4, the test for 4, if the last 2 digits form a number that is divisible by 4, then the original number is divisible by 4. Let's try. 5,124. 24 is divisible by 4. It's 6 times 4, right? And so 5,124 is divisible by 4. 348, the last 2 digits are 48, divisible by 4, and so 348 will be divisible by 4. Among the numbers that are not, 722, not divisible by 4 because 22 is not. 914, not divisible by 4 because 14 is not divisible by 4. Okay, the test for 5 is pretty easy. If the number ends in either 0 or 5, it's divisible by 5. Examples are 35 and 400. If somebody was going to pay you $35 or $400, they could do it all in 5s. 53 and 87 don't end in either 0 or 5. You couldn't pay somebody exactly $53 or exactly $87 using $5 bills. Okay, the 9 test is really similar to the 3 test, only you're kind of doing it for 9 instead of 3. 171, that looks kind of like a prime number, but if you say 1 plus 7 plus 1 is 9, 9 is divisible by 9, of course, and so 171 is divisible by 9. 684, I'll leave that one for you to check. Actually, let me do that one. 144 is easy. Let me do 684. 6 plus 8 plus 4, that's 18, and 18 is divisible by 9. So that means that 684 is divisible by 9. You can check that 39 isn't. 39, 3 plus 9 is 12, while 12 is divisible by 3. 39 would be divisible by 3. It's not divisible by 9 because 12 is not divisible by 9. And the same thing can be said for 78. Okay, so the divisibility tests are useful if, as we'll see when we work with fractions, if you want to simplify a fraction and you need to know, will it simplify or not? a fraction like 5/40ths, you can see that both 5 and 40 are divisible by 5. And so you can divide out that common factor of 5. 3 over 51, that's going to simplify to 1/17 because you know that 51 is divisible by 3, right? So that's the main use for these divisibility tests. Okay, let's try a couple of examples. So here it says, in the following exercises, use the divisibility test to determine whether each number is divisible by 2, 3, 5, 6, and 10. So let's try number 40, 44, and 48. Let's just do those three. Okay, for 78, we want to check and see if it's divisible by 2, 3, 5, 6, and 10. Okay, for 2, yes, because it ends in an 8. Okay, for 78, is it divisible by 3? 7 plus 8 is 15. And so that's divisible by 3. So it's going to be divisible by 3. 78 will be. Okay, 5, it ends in an 8, which is not either 0 or 5. So it's not going to be divisible by 5. Divisible by 6, we didn't talk about a divisibility test for 6, but if you think about it, 6 is 2 times 3, and if you could divide by both 2 and 3, then you could divide by 6. So I'll leave it to you to think about that. For 10, we didn't see a divisibility test for 10, but it doesn't end in a 0, so I'm saying no. All right, so take a minute and pause the video and try this for 942. And then restart the video and see how you did. Okay, all right, so for 942, it ends in a 2, and so it's going to be divisible by 2. For 3, let me add up the digits. 9 plus 4 plus 2, that's 13, 15. And 15 is divisible by 3, so that means that 942 will be divisible by 3. 5 looks like the answer is no. It ends in a 2, which is neither a 0 nor a 5. For 6, it's divisible by both 2 and 3, so we'll say yes. And 10 looks like no. All right, so I happened to pick out one that was the same as 78, so that's interesting. 48 will be more interesting. 39,075. We had 2, 3, 5, 6, and 10. All right, so it's not going to be divisible by 2 because it ends in a 5, which is an odd digit. 3, let me add up the digits. 3 plus 9 plus 0 plus 7 plus 5. That's 12, 19, 24. Is that 24? 12, 15, 24. Yeah, it's 24. 24 is divisible by 3. And so that means that our original number, 39,075, is divisible by 3. Divisible by 5 this time because it ends in a 5. Divisible by 6, no. If it was going to be divisible by 6, it would have to have been divisible by 2, and it's not. And so, no. Is it divisible by 10? No, it doesn't end in a 0, so we'll say no. All right, so those are the divisibility tests. If you have any questions on those, let me know. Okay, the next subtopic for this section is about rounding and estimating. So let's take a look at that. Let me turn off those lines first. Okay, so rounding and estimating. So first of all, what's the difference and the value for each? An estimate first is an approximate number or approximate answer. If you want to make an estimate of something, you're making a guess or an approximate answer. Okay, why you would make an estimate is there's two reasons why you would make an estimate versus getting an exact answer. Sometimes speed is more valuable than accuracy for a particular question. If you're going to go to the grocery store, let's say, and you're going to buy 3 cans of tuna at $1.19 each, that's 3 cans at $1.19 each, and you have a $10 bill, will that be enough? Yeah, pretty easy to see that that's going to be enough. If you had a $5 bill, that's a little bit takes a little more thinking, but yeah, that one should also be okay. There, we don't need to know the exact answer in order to know just the answer to the question, yes or no, will it be enough or not. Okay, however, sometimes a answer that's more accurate is more important. And so then we get an exact answer, like if you're trying to find the medication dosage for cold medicine for your kid or something, you're not going to want to produce an estimate, but an estimate is sometimes close enough is good enough. Okay, other times, error detection. If we come up with an estimated answer, it can help us determine whether we've made a mistake or not. For example, if I asked you to add, I don't know, 314 plus 576, and you got 1980. Okay, well, that should be pretty obvious that it's wrong, right? Because it's like a little over 300 plus about 600. If it was like 300 and 600, it would be like 900. There's no way I could have gotten 1980 for that. So it's obviously wrong, right? So that is a example to illustrate why we might use estimating is to help us catch an error that we may have made. Out of the different ways of producing an estimate, rounding is one of the ways that we have of making an estimation. Usually when we do rounding, we say in these kind of contrived problems that you're likely to see in the assignment, we usually say round some number to the nearest, and then whatever goes in this blank is going to be some place value. So round to the nearest 10th, 100th, 1000th, or whatever it is, right? So for example, we'll take 26. If we want to round 26 to the nearest 10, here up on the number line, you can see that there's a blue dot there. 26 is closer to 30 than it is to 20. Then rounded to the nearest 10, 26 is going to be 30. What that means when we say round to the nearest 10, we want to find a multiple of 10 that is, out of all the different multiples of 10, we want the one that is closest to 30. Okay, so sometimes we round up. 52, if we want to round 52 to the nearest 10, 52 is actually closer to 50 than it is to 60, so we would round down to 50. And so there, the final answer is going to be 50. If you have a number that is exactly halfway between, right, 25 is exactly halfway between 25 and 30. The rule, just kind of the custom there, is to round up. So we would say that's 30 when rounded to the nearest 10. Okay, so there's no mathematical reason for that. It's just a rule. Sorry, that's kind of artificial, but that's the way that it goes in this case. Okay, so steps to follow. If you're a person who likes steps, here's a procedure that you can use. Locate the digit to the right of the given place value. What is meant by the given place value is whatever comes after nearest. Are you rounding to the nearest 10, 100, 1000, whatever it is? Whatever comes after nearest, that's what they're saying in the directions here is the given place value. Okay, then if this digit is, okay, so we want the digit to the right of that given place value. Comparing that digit to 5, if it's 5 or greater, add 1 to the given place value and replace each digit to the right by 0. If it's less than 5, then replace it and each digit to the right by 0. So that's kind of long and not that easy to follow. So let me try to illustrate it with an example. So we're going to round 2,563 to the nearest, let's do 10, then 100. Okay, and then you'll see what I mean. Okay, so first we're going to round this one number, 2,563, to the nearest 10. Okay, what digit is in the tens place? It's a 6. Okay, step 1, locate the digit to the right of the given place value. To the right of the 6 is the 3. Okay, you're looking at the 3. Is that more or less than 5? Okay, it's less than 5. So take a look at step 3. If this digit is less than 5, replace it and each digit to its right, aren't any, by 0. So it'll be 2,560. Okay, so let's try that again. If we went around to the nearest 100 instead, then the nearest place we're talking about is 5. That's in the hundreds place. Now the digit to the right of that is the 6. The 6 is more than 5, so we're going to add 1 to that 6. Sorry, we're going to add 1 to the given place value, so that should be 26, and then the digits to the right will turn into zeros. Okay, so 2,600 would be the nearest. If you like step-by-step directions, this may appeal to you. My personal choice is to draw a picture. I find that to be easier. So I'm going to demonstrate that on the next couple of examples. Okay, so to me, I like to visualize or even draw out a piece of number line to help me with this. So here, when we want to think about 568 to the nearest 10, I visualize multiples of 10. So 568 is between 560 and 570. Okay, is 568 closer to 60 or 70? It's closer to 570, right? So that's 568 to the nearest 10. Okay, so now 278,362 to the nearest 1,000. Well, I know it's bigger than 278,000 and smaller than 279,000. Okay, so number line, 278,362. Well, that's closer to the low end, right? Exactly halfway between would be 278,500. Anything less than that, and we're going to round down. So it'll be 278,000. Okay, 248,982 to the nearest 100. Okay, 982 is, I can kind of forget the digits in front for a second. 982, is that closer to 900 or 1,000? It's closer to 1,000, right? So we're going to bump this up to 249,000. Okay. All right, notice that that ended up a multiple of 1,000 just because we were already at 982. Okay, here's a couple to try. Pause the video and try this yourself using either the steps to follow method in writing or by drawing a number line, your choice. Then restart the video and see how you did. All right, so we want 2,735 to the nearest 1,000. So 2,735, that looks like it's pretty close to 3,000. It's definitely closer than it is to 2,000. To the nearest 100, is it closer to 2,700 or 2,800? Okay, well, 2,735 is under 2,750. It's closer to 2,700. To the nearest, sorry about that, Zoom quit on me for a moment. Let's see if it's back. 2,730 to 2,740. 2,735 is exactly halfway between. And so the custom for that is that we'll round up and call it 2,740. Okay, so that takes care of that. And that actually is our last example for section 1.1. Take a look through all of the textbook, make sure that you're reading that, and then make sure that you let me know if you have any questions, and then have a great day.